Hey science fans, welcome along. Today I'm going to talk about the model gut, because quite often people, they've got all the knowledge but then they can't apply it to something that looks a little bit weird. This is a picture of the model gut. So it's essentially a piece of visking tubing in a beaker. Now I've done a video about diffusion using this method. Usually we use this to talk about either food tests, enzymes and diffusion across a membrane. I'm just going to show you the sort of basic activity they might ask you about in the exam, but quite often these are poorly answered and they're very, very simple. And it's just because people misunderstand the mechanics of everything that's going on. This is AQA, it's biology, it's everyone, triple, trilogy, whatever you're doing. Let's get cracking. This here is called dialysis membrane or visking tubing. Now, what it essentially is a tube. You'll be able to see in a minute that you can actually pass things through it. And it is called dialysis membrane because it is, or visking tubing, because it has very small holes in it that certain substances can diffuse through. Now, large substances like starch will not be able to pass through the holes in this membrane. It is a partially permeable membrane, whereas something like glucose and water will. And we can use this as a model gut because it behaves in the same way your blood vessels do and also your gut does, or your intestines does, in the way that it will allow certain small substances to pass from one place to another. See, now I've got it wet, it's opening quite well, so it becomes really flexible. So now I could fill it with water if I wanted to. Apparently I do want to because I'm doing it right now. Just filling it up with a pipette. This is also really good because it can also become a model for a cell because it has a partially permeable membrane like a cell. So I could use it to show osmosis if I wanted to, because I could show it being very turgid or very flaccid. Okay, so there we go. That is my model gut there, and I can now fill this and show, I can fill this with any liquid that might be digested in the gut. So I could put starch in there, I could put fats in there, etc. And then I could put in an enzyme to show it being broken down, which is the experiment that I'm going to do today. So here I've got some starch solution. Starch is a carbohydrate. It is a long chain of glucose all joined together. It is not digestible because it is not soluble. So we digest it to make it soluble. So I'm going to use starch solution. This is starch solution, very much proved by the fact that it says, whoops, starch solution on the front. And I could easily test to see if this is starch solution, which I'm going to do in a minute. Okay. And that is now ready to go into my boiling tube. So just to prove that this is in fact starch, we test for starch using iodine. I'm going to take some of that, pop it in there. Then I'm going to take some iodine, pop it in there, and it should go blue black in the presence of starch. Which it has. Okay, so this is now full of starch. Okay, I've washed the outside of it so that it doesn't have any starch on the outside. And what I'm going to do is I'm now going to pop this into a boiling tube. Whoops, a daisy. Into a boiling tube or a beaker with an elastic band around the top. And then I'm going to pop it into a water bath. Oh, that was a noise. Here it is. So this is my model gut. This is the water bath, the boiling tube. Could be a beaker. Went with a boiling tube, not sure why. You can just, I put it in the light so you can just about see the visking tubing in there. And that's got starch in it. I'm going to keep it all at the same temperature in an electrical water bath at 30 degrees C. And then I'll see whether the starch has made it through my gut. Shouldn't do. I'm also going to make one ready to go that has amylase and starch in it. So the amylase in with the starch, the amylase, the enzyme, should digest the starch into glucose, which can fit through the small pores or holes in the membrane, in the visking tubing. So therefore I should be able to test for sugar in the water bath water. Let's go. Just going to make one with amylase and starch in it, so hopefully we should be able to test that the amylase has broken down the starch, digested it into the soluble glucose, and then we can test for glucose in the water bath to see if it has passed through the partially permeable membrane. Let's go. Here they are in the water bath. So this is the starch and this is the starch and amylase. So I'm going to, in my table, the tube with starch, and I'm going to test for starch, and then I'm going to test for sugar. And the test for both, I'm going to test for starch, And I'm going to test for amylase, and I'm going to leave them for 30 minutes to do their work. Let's go.
I am just going to, now it's been 30 minutes, I'm just going to test both of the water in these water baths. I'm going to test them for starch and I'm going to test them for glucose, okay? Now, the starch is too large, in theory, to fit through this model gut, this whisking tubing, so I should find nothing, okay? So I'm going to remove some of the water. I realise there's a giant kettle in the way. Remove that. And I'm going to test for starch. Now, I should see no starch. Oh, that is good news. No starch, which means no starch has gotten onto the outside. I should also see no sugar. So I'm going to test for sugar. And I'm going to use Benedict's to do this. So I've got my Benedict's in here. This needs to be hot, so that's why I've got my kettle here. And I'm going to put some of this water in here. And I'm going to pop it in hot water. Now, if sugar has got through here, this is going to turn green and then brick red. So I'm just going to pop this in here with some boiling water. And if that goes green, we know that somehow that starch is broken down. Not sure how. Okay, I'm going to do the same thing with this one. So I'm going to test to see if I've got any starch has come out of that whisking tubing into the water. Still yellow, well, orange. So no, fortunately, no starch has gotten through that. So I'm now going to test for sugar. So I'm going to take some of that, pop it in there, and I'm going to got my starch here and my amylase and starch here in my Benedict solution to see if they contain glucose. I've put them in boiling water, but I'm probably actually going to need to boil those and see if they turn red. After a couple of minutes, you can see that the one with the amylase and the starch is producing this yellow colour, which means it definitely is containing some glucose. I'm going to leave it in there. It should turn like a brick red colour. Whereas the one that had just starch in it, still bleu.
L'orange. So that's it. Hopefully you can see that the model gut isn't particularly scary concept, not particularly difficult. Examiners like it because it kind of links lots of things together. It can link together solubility, it can link together osmosis, diffusion, active transport, digestion, solubility, insolubility, the food tests and indicators and things like that. So it's quite a lot. I mean, once they did something about protein being broken down and having an indicator here that went red, and so that showed that the protein had been broken down into amino acids. So they can use it for all sorts of things. But yeah, take care, stay safe.